Hi everyone, hope you all are doing well. Welcome back to my YouTube channel. Today we will discuss about gravimetric analysis. Gravimetric analysis. It means quantitative analysis by weighing it is an analytical technique based on the measurements of mass of solid substances or volume of gaseous species. It is a quantitative analysis in which the end product is weighed and from the weight composition of analyte is determined. Hence, gravimetric analysis is based upon the measurements of the weight of a substance of known composition which is chemically related to the analyte. In the gravimetric analysis, there are mainly four types. First one, precipitation gravimetry, volatilization gravimetry, electrogravimetry, thermogravimetry. We will see one after the other. First one is precipitation gravimetry. This involves chemical precipitation of the constituents. Next is volatilization gravimetry. In this method, the constituents are decomposed due to volatilization at the suitable temperature. Next is electrogravimetry. This involves the electrochemical reduction of the metal ions at the cathode and simultaneous decomposition of the metal ions at the cathode. Next is thermogravimetry. In this type, the sample is heated and with the change in temperature, changes in mass of the sample are recorded. And next is step involved in precipitation gravimetric analysis, that is first one, that is precipitation gravimetric analysis. This involved preparation of the test solution. Next is precipitation. Next will be digestion of precipitation. After this, filtration of precipitation. After filtration, washing of the precipitate formed. Next, after washing, the further step is drying the precipitation or ignition of precipitate. After this, we have to weigh the precipitate formed. After weighing of the precipitate formed, then there comes the last step, that is calculation. And after calculating, we have to write the result as percentage of yield obtained, that is weight. In this slide, you can observe two types of precipitations, that is first one is crystalline precipitate. This precipitate is relatively pure and easily filtrable. And the next one is Kurdi precipitate. This precipitate is colloidal particle size but are filtrable. Here the crystalline are in crystal form. And Kurdi precipitate is in the form of curd which are totally settled at the bottom of the test tube as shown in the slide. And the third one is gelatinous precipitate. This precipitate is flocculated colloids. The precipitate size is smaller than curdy precipitate and difficult to filter. As you have seen in the curdy precipitate, they are settled at the bottom. But whereas in the gelatinous precipitate, the precipitate floats on the water by not settling at the bottom. This is a difference between the curdy precipitate and the gelatinous precipitate. Next is conditions for precipitation. Precipitation is an ionic reaction of mixing of positive ions of one substance and negative ions of another substance to form a sparkling soluble substance. The completeness of the precipitate depends on equilibrium solubility of a precipitate. The solubility of any substance is defined as the amount of substance dissolved in a solvent at a given temperature and is expressed in grams per dm cube or moles per dm cube. Next is solubility product. Solubility product is defined as the product of concentration of the constituent ions raised to a appropriate power depending on the number of ions present in the molecule of the compound, that is saturated solution. You can observe the equation given below. A is in the equilibrium to C plus D. Ksp equals to concentration of C into concentration of D. Next, both the solubility and solubility product are temperature dependent. If temperature increases, solubility and solubility product is also increases. Next, the most important condition for precipitation is that the ionic product must be greater than the solubility product of the salt. The conditions are given. When ionic condition is greater than solubility product, then the precipitation is formed. And the next condition is ionic product is equal to the solubility product, then the saturated solution is formed. Then the third condition is ionic product is less than solubility product, then the unsaturated solution is formed. The saturated solution is nothing but it is formed by the single bond, that is for example methane, ethane. And next is unsaturated solution. This solution is formed by double bond and triple bond, that is methene, ene and methyl. These types of solutions are called saturated and unsaturated solutions. Next, coming to factors affecting the solubility product and completeness of the precipitates. First one is common ion effect. Presence of an ion common with ions of the salt decreases the solubility of the salt. The solubility of the salt is less in presence of common ion compared to pure water. This effect is known as common ion effect. Here is one of the example for the common ion effect. You can just copy it in your notes and see. And the second effect is diverse ion effect. If the solubility of sparkling soluble salt increases in presence of foreign ions, that ions are not common to those of the salts. This effect is known as diverse ion effect or salt effect or activity effect. This effect has three names, that is diverse ion effect, salt effect and activity effect. And next, the example for diverse ion effect is solubility of barium sulfate increases by 70% in 0.1 molar solution of potassium nitrate than in water. And next is temperature. Solubility of any salt increases with increase in temperature. The increase in solubility of two salts with the increase in temperature may be different. Example, solubility of AgCl in water increases 12 times with temperature is increases from 273 Kelvin to 383 Kelvin, while at the same increase of temperature the solubility of barium sulfate in water is doubled only. And next is pH. I hope everyone knows that is pH means power of hydrogen. The solubility of substance depends on pH of the solution from which that is precipitated. The change in pH is brought by addition of strong acid or a strong base. If the salt is of strong acid or strong base type, then addition of acid or base will produce diverse ion effect. This increases the solubility of small extent. On the other hand, if the salt is of weak acid or weak base, then solubility increases by high extent. Considering an example, consider a salt of weak acid a strong acid is added to change pH. The hydrogen ion form the added strong acid react with an ion of salt and form the weak undissociated acid. To maintain the solubility equilibrium, more and more salt dissolves. Next, coming to the complexation. In many cases, precipitating agent itself may act as a complexating agent, dissolving the precipitate by converting it into the complex. This is known as complexation. Next, here I have got an example. The cyanide ion acts as precipitating agent for silver ions forming precipitate of AgCN, that is silver cyanide. But the AgCN is dissolved in excess of cyanide ions forming a complex, which is given here. You can observe the equations given below. Next is nature of the solvent. Polar solvents like water will always favor dissolution of the polar or ionic solute, but nonpolar solvents not favor dissolution. Here is an example. Solubility of a salt like calcium sulfate in water can be decreased by addition of a less polar solvent like ethanol to it. And our next topic is controlling particle size. The purity and filtrability depends upon the particle size of the precipitate. If there are colloidal suspensions which are visible to naked eyes, are not easily settled down and not easy to filter. On the other hand, if crystalline precipitate is formed, it is easily get settled down and easily filtered. During the precipitation process, initially small particles known as nuclei are formed and subsequently the size of these nuclei is increased to large enough to settle down. The particle size is therefore determined by the relative rates of nucleation and growth of the crystals. This was about the controlling particle size. And the next one is the process of nucleation. Precipitation is being with the attraction of ions towards each other due to electrostatic force between them. This results in the formation of ion pairs. These ion pairs grow further by the addition of ions or ion pairs to form ion clusters. Here is a diagrammatic representation. You can observe it. The ion pair and ion cluster formation takes place even when ionic concentration has not excluded the solubility product of the substance which has to be precipitated. The ion clusters can be separated easily into ion pairs till they attain some minimum size known as critical size. Once the critical size is attained, the ion clusters become nucleus and continues to grow to form crystals. This you can observe in the figure given below. As you have seen the process of nucleation, now you can see the types of process of nucleation. In this there are two types. First one is heterogeneous nucleation process and homogeneous nucleation process. Heterogeneous nucleation process. In this process, nuclei formed by clustering of ions around another particles. Homogeneous nucleation process is the second type. In this process, nuclei formed by clustering of ions by themselves and arranging in a definite pattern. According to von Neumann, if particle size is smaller, the faster is precipitation. He found supersaturation plays an important role in determining the particle size of a precipitate. That is, relative supersaturation equals to Q minus S whole divided by S, where Q minus S is the supersaturation at the moment particle starts. Q is molar concentration of mixed agents and S is molar solubility of a precipitate at equilibrium condition. Experimentally, it is found the particle size varies inversely with relative supersaturation. When Q minus S divided by S is large, then particle tends to be colloidal. Whereas it is opposite in next condition, where Q minus S whole divided by S is small, then particle size tends to be in a crystalline solid. These are the two conditions in formation of supersaturated solution. The precipitation process occurs in three stages. First one is nucleation, second one is formation of colloidal particles, and next is growth of colloidal particles. First one, nucleation. Collision of ions in supersaturated solution to yield primary nuclei. Second one, aggregation of ions around primary nuclei forming colloidal particles. And the third one is growth of colloidal particles, that is, growth of colloidal particles to form a particles which settle as precipitate. Here is a flow chart of nucleation, colloidal particles and formation of precipitate. Now let us see what is colloidal state. The colloidal state has particle size ranging from 1 nanometer to 10 raised to 3 nanometer. Charge on colloidal particle arises due to absorption of ions on the surface of the catalyst. Due to charge, these particles migrate in an applied electrical field and collided particles scatter light. The scattering effect is known as Tyndall effect. I hope you all know about the Tyndall effect since you have studied it in your 9th and 10th classes. Next, colloidal particles are involved in the random motion which is known as Brownian movement. These particles absorb ions from the solution which are present in large concentration in the solution. Following are the three diagrams from which you can understand about the Tyndall effect and what is colloidal particles, and also you can see the size of the colloidal state. Impurities in the analytical precipitate. Once the precipitate is formed, it has to be treated as it can be contaminated. The contamination of a precipitate is due to two reasons. First one is co-precipitate and second one is post-precipitate. This can also be considered as types of precipitations, that is co-precipitate and post-precipitate. Now let us see what is co-precipitation. The phenomenon in which the impurities is soluble and it is precipitated along with the main precipitate, causing the contamination of precipitate, is known as co-precipitation. And if asked, you can write the definition of co-precipitate as given above. Next is post-precipitation. The phenomenon in which an impurity which occur on the surface of the first precipitate after the appreciable time is known as post-precipitation. That is, formation of a precipitate after leaving the precipitate for the longer time in a mother liquid is known as post-precipitation. Here also the contamination occurs. The contamination of precipitate is removed by digestion, filtration and washing. After studying about the types of precipitation, now we have completion of precipitation. When the beaker containing the precipitate is allowed to stand in water bath for digestion, after some time the precipitate settles down and the clear solution is obtained above the settled precipitate. Completion of precipitate is confirmed by adding little volume of precipitating agent from the walls of the beaker. If there is no more precipitation forms, indicates the completion of precipitation. This says about the completion of precipitate. Hope you all are clear with precipitation. After precipitation, the next step will be digestion. When the precipitation is carried out from the concentrated solution, the particles of precipitate obtained have imperfect structure and size. Such crystals are difficult to filter. This can be resolved by keeping such precipitate for digestion. What is digestion? Digestion is a process in which the precipitate is allowed to stand for an hour or more in contact with the hot solution from which it is formed. You can observe the diagrams shown in the slide. The golden yellow color thing is a precipitate formed which is not in the perfect size. After keeping it to the digestion in the digesting machine, you can observe it in the second diagram. Next, after keeping it half an hour in the digestion, and third diagram is observed. After digestion, all the colloidal particles that is settle down in the bottom of the container. Now it is easier for the filtration process. This is about the digestion. After digestion, the next process is filtration. Filtration is the separation of precipitate from the mother liquor. The main object of this is to obtain the precipitate from the free solution. Precipitation is carried out by two ways. First one is filtration by using filter paper. Whatman filter papers are in many number, that is 40, 41 and 42 are commonly used number of filter papers. Whatman filter paper, which is ashless, is used for the filtration. Three qualitative of filter papers are generally made. First one for fine particles, second for average precipitate of medium sized particles, and third for gelatinous and coarse particles. The precipitate collected on filter paper is further dried and ignited to a constant weight. Here are the diagrammatic representation of process of filtration. The first one is Whatman filter paper, and the second is how the process of filtration is done from the precipitate, and the third one is separation from Buchner funnel using filter paper. This kind of filtration is commonly used. And also we have the second kind of filtration process. Filtration by counterpoise method. In this method, sintered glass crucible is used for filtration. The sintered glass crucible are made up of resistance glass and have a porous disc of sintered ground glass fused at the bottom of the crucible. Here the first diagram shows the sintered crucible. During a filtration, a previously weighed sintered crucible is connected to vacuum pump and filtration is carried. Precipitate is washed with appropriate wash solution. After filtration, the crucible with precipitate is dried in an electric oven at the constant temperature. Finally, the weight of the crucible with precipitate is recorded, from which weight of precipitate is obtained, which used for further calculation. This was about the two types of filtration process involved. After filtration, the next process will be washing. Most of the precipitates are obtained in presence of one or more soluble compounds or contaminants. As these are non-volatile at the temperature at which the precipitated is dried, It is necessary to wash the precipitate to remove such substance completely. Characteristics of washing solution. First one, it should have no action on the precipitate but capacity to dissolve the impurity. Next, it should not form any volatile or insoluble substance with precipitate. And the third one is, it should be volatile at the temperature of drying of precipitate. These are the three characteristics of washing solution. Water is mostly used as a wash solution if precipitate is insoluble in water. Whereas if precipitate is soluble in water, then an electrolyte containing common ion is added in water and then it is used as wash solution for washing. Next is drying and ignition of precipitate. Heating of precipitate below 250 degrees Celsius is referred as drying. The purpose of drying and ignition of precipitate is to obtain a compound of known and constant composition. During this drying, the water associated with the precipitate is also get removed. The drying is depending on the way in which filtration is carried out. If the filtration is carried out, first point is, if the filtration is carried out in a sintered glass crucible, then the drying will be done in an oven with the temperature ranging between 100 degrees Celsius to 150 degrees Celsius. Here the crucible, that is sinter crucible, is kept in the machine and it is allowed to stay in the oven for 10 to 15 minutes until it is dried. Later on, the crucible is taken out of the oven and kept in the desiccator for 10 to 15 minutes, and after it is at the constant temperature, it is weighed and the weight is measured. If the filtration is carried out with the Whatman filter paper, then the filter paper along with the precipitate is dried on the cone with care, and then the filter paper does not shared in the process. The precipitate along with the filter paper is ignited to white ash in the crucible. The crucible is cooled at room temperature and then transferred into the desiccator and finally weighed to a constant weight. Here the first figure shows the cone and the second figure shows the crucible and the third figure shows the oven and the fourth figure shows the desiccator. So these were all the steps involved in the measurement of the weight of the product obtained at the end. I hope you understood. Thank you for watching this video. I hope you understood all the concepts. If you have any doubts, please comment in the comment section. Thank you everyone.